Let's do some very quick Regents chemistry review with the most common questions that show up on the Regents exam. So we'll go by one topic at a time, and for each slide that you see, take a moment to pause and try to answer the questions before you listen to the explanations. So here we have our first topic about matter and changes, and here are a few questions. If you look at the first one, all matter can be classified as. You can memorize this little chart that you see over here. So matter is in general classified as either a substance or a mixture. And then substances are further classified into elements or compounds. So elements are the simplest type of substances, and then compounds are made of multiple elements, multiple different elements. So if you look at this chart, based on this, an element or a substance, they're basically the same thing because an element is a substance, so that is not your answer. Matter is not only classified as an element or as a compound, so the last option that we are left with, which is closest to the correct answer, is D. And then in the next one, it says which answer is correct for X and Y, X and Z. So as we just said, X is a substance, and substance can either be an element or a compound. So, and then Z is going to be a mixture. So the correct answer here will be D. Then we have number 3, which sample can be classified as a substance. So once again, substance is something that is not a mixture. So we are looking for either an element or a compound. So if you look at your options, we know from prior knowledge that seawater, air, and soil, they are all mixtures of multiple substances. So the correct answer here is argon, which is an element, argon gas. Then we have which substance contains elements chemically combined in a fixed proportion. Please make sure that you have memorized this. This concept is on your fingertips. Whenever we have elements combined in a fixed proportion, this is referring to a compound. If we have mixtures, mixtures do not have any fixed proportion. We can always change how much of one thing do we want to add in the mixture. But in case of compound, if you want to make H2O, which is water, we need 2 atoms of hydrogen and we need 1 atom of oxygen. If we change that, that is not going to be water. So we are looking for a compound in our options. So manganese, Mn, this is an element. Then we have strontium, which is also an element. Methane, this is something that you should memorize because methane is a very common compound in chemistry. So please make sure that you know the formula for methane. It's CH4. And then we have silicon, which is also an element. So the correct answer is B. And just a very quick trick, if you are not sure whether something is an element or a compound, you can always look at your table S. So table S doesn't have all of the elements, but normally the ones that do show up on the Regents exam, they are named in table S, so you can always look there to verify if something is an element. Then for number 5, which substance can be broken down by a chemical chain. So we are talking about something that can be broken down. So this refers to a compound. Now the reason why we only said a compound and not a mixture is because we are talking about separation by chemical means, meaning there is a chemical reaction that needs to occur to break down that thing. Mixtures can be separated by physical techniques. So physical techniques are things like boiling, filtration, distillation, all of those techniques. So we are looking for a compound in our answer. And once again, go to table S. If you want to make sure which thing is an element, eliminate those options. And so your answer here will be ethane, which is an organic compound. So this one is C2H6. Then we have which substance cannot be broken down by a chemical chain. So remember that when you see this question, the question is not saying which thing can be broken down by a physical change. That is not what the question is referring to. So physical change is absolutely not mentioned in this question. We are talking about something that cannot be broken down at all. So that means we need an element as our answer. So once again, use table S, figure out which thing is an element. So that will be magnesium in this case. Methane, ammonia, and water, you should ideally remember the formulas for these things. Methane, as I already mentioned, is CH4. Ammonia is NH3. That's your ammonia gas. And then water is H2O. Right, moving on. Here are some more questions from this topic. So if you look at number 7, a sample is composed of 2 different substances that can be separated by using filter paper. So this sample can be classified as, so when we are using a filter paper, that means we are using a physical method to separate something. So this is going to be a mixture. But now the question is it going to be a heterogeneous mixture or a homogeneous mixture? So heterogeneous mixture could be something like, let's say, salt and water. And then your homogeneous mixture can be something like, sorry, I apologize, I switched those two. So your homogeneous mixture is something like salt and water, because salt dissolves very quickly and very well in water. So everything looks the same. We don't see any separate layers. We don't see any particles. Everything is well dissolved. The particles are evenly distributed. But if you look at a mixture of, let's say, what do I want to say? Let's say soil and water, or sand and water. So they are going to be insoluble. So you will see some sand particles, soil particles either at the bottom of the water. So that will be a heterogeneous mixture, because if you want to separate them, you can get the sand on the filter paper, and then the water should be able to go through the filter paper. In case of a homogeneous mixture, nothing is going to stay on the filter paper because everything is dissolved in the solution. Then we have which sample of matter is a mixture. So this thing is something that should be answered in like 5 seconds. All you have to remember is that solids, liquids, and gases, if they are in their pure form, they are not a mixture. Or at least we have not talked about in this class about the solid, liquid, or gas mixtures. So whenever you see an aqueous solution in your answer, that is your answer if the question is asking for a mixture, because aqueous solution means you have something dissolved in water. So in this case, we have magnesium chloride that is dissolved in water. For number 9, which statement describes the components of a mixture? So our options are: each component gains new properties, each component loses its original properties, the proportions of the components can vary, the proportion of the components cannot vary. So we already talked about the proportions, and we said that in case of mixtures, the proportions can change. The reason why 1 and 2 is not your answer is because when you are mixing 2 things, let's say you are mixing sand and salt, they are not gaining any new properties. They are just making a solution. And when we separate those 2 things, when we separate the sand and the salt, they're still going to have their original properties. So they are not gaining new properties. They are not losing their original properties. And we can always change the proportion in which we are dissolving them. So your answer is C. Which sample of matter can be separated into 2 different substances by physical means? So once again, here, this is the question that is the opposite of what we were looking at the previous slide. Now we are looking for a mixture. So if you look at your options, once again, you have a gas, a solid, and a liquid, and then you have an aqueous mixture, aqueous solution, which we know is a mixture. Next up, it says, state in terms of particle distribution why the solution is classified as a homogeneous mixture. Now, please make sure that if the question says in terms of something, you do not ignore that part. So when you are answering this question, we do know what a homogeneous mixture is. I'm sure you all know what a homogeneous mixture is. This is when both the solute and the solvent are dissolved completely. Although that answer is correct, but when you answer this, you will not say that a homogeneous mixture is the one where the solute and the solvent are completely mixed or completely dissolved. In fact, what you're going to say is that a homogeneous mixture is the one where the particles are evenly distributed, because that's what the question is asking. So if you do not mention the words that are mentioned in the question, even if your answer is hypothetically correct, you are still not going to get the points, because that just means you didn't read the question correctly. So moving on to some more questions on matter and changes. So number 12 is saying which process can be used to separate a mixture of two liquids having different boiling points. So this will be your distillation, and the apparatus for the distillation is actually shown over here. So remember, this is if you we use distillation whenever you have two liquids that are completely dissolved. So for a homogeneous mixture of two liquids, and then we put them in this first flask and we start boiling them. Because they both have different boiling points, one of them is going to boil first, and when it boils, it's going to be collected in this beaker. So once we go past the boiling point of that first liquid, because we are recording the temperature using this thermometer. So once we go past the boiling point of that liquid, we know that we have most likely at least 95%, if not 100%, we have collected most of the first substance. So that's when we remove this beaker and we stop distillation, because whatever we have left in our initial beaker now is going to be the other substance or the other liquid. So this apparatus is for distillation. Then we have table sugar can be separated from a mixture of table sugar and sand at STP by adding what? So in this mixture, we have sugar and sand. So the first thing that we would want to do, because if we just take both of these things in the solid form, we cannot use filtration for this, because technically both of them are just solids. They are both going to stay on the filter paper, and there is no technique that we have learned to separate two solids from each other. So what we're going to have to do is dissolve this mixture of sugar and sand into water, because now what's going to happen is that the sugar is going to dissolve, the sand will not. So once we have that sugary solution, sugar water solution, and the sand, we can now go ahead and use filtration. Filtration is going to get the sand on top of the filter paper, and then we are going to evaporate the water from the rest to get the sugar. So this procedure will be option C, adding the water first, stirring to make the mixture, and then filtering out the sand. Although there will be a fourth step, which will be evaporation, but because that is not one of the options, so it's fine. We'll just ignore it. For the next question, explain in terms of particle size why the rock particles are trapped by the filter paper. Remember, filtration depends on the particle size. This is also a very common question. It just didn't show up on the exams. It hasn't shown up specifically on the exams that I looked at, but just make sure that it can show up. You should remember that filtration depends on the particle size, because the things that are bigger or that have a bigger particle size than the pores in the filter paper, they are going to stay on top of the filter paper. So when you answer this question, you're just going to say the particle size of the rock particles is bigger than the pores of the filter. That's your answer. So once again, if you don't mention particle size, your answer will be incorrect. So here are some more questions. Number 16 is asking for a physical change. So remember, physical change is something where the substance is not changing its chemical composition. So we are looking for the same chemical composition on both sides. So some examples of physical changes are phase changes. So in this case, if you look at all of the reactions, you can kind of see that except the first option, pretty much in all of the rest of the equations, the chemical composition is changing. So either the things are combining, or they are breaking down, or just converting into something different. So your answer will be A in this case, because all that's happening here is we are going from the solid phase to the gas phase, which is a phase change. For number 17, which statement describes a chemical property of copper? So chemical property is once again a property that if changed, will change the chemical composition of that substance. Meaning, if we change this property, then that substance is not going to be copper anymore. So if you look at option A, that says it can be flattened into sheets. It's just a different shape, but it's still copper. Then copper has a red-orange color. Again, color is normally classified as a physical property. Unless we react that substance with something and then we notice a color change. Copper conducts an electric current. Conductivity is normally also a physical property. And then lastly, we have option D, which says copper reacts with oxygen. So here we are talking about a reaction, because of course when we react copper with oxygen, it's going to become copper oxide, which is not going to be copper anymore. So your answer will be D. For number 18, at STP, a 50-gram sample of water that's in the liquid phase and a 100-gram sample of water that's in the liquid phase as well have. First option is different temperatures. They already told us in the question that they're both at STP, so this is not your answer. They have the same temperature. The same volume. The question doesn't give us any information about the volume, so we can just cross that out. They have different empirical formula. So empirical formula is, remember, the least possible ratio of the formula. So the least possible ratio in this case is still going to be H2O. So that is also the same because it's still water. So that's not your answer. And then they have the same chemical properties. So remember, as long as it's water, the mass doesn't matter. You can take 50 grams or 100 grams. They are still going to have same chemical properties. Which process represents a chemical change? So once again, we are looking at a change that is going to change the chemical composition. So number one, a candle burns in air. When you burn the candle, it's not a candle anymore. So this one does change the chemical composition. So that is a chemical change. Iodine sublimes. Sublimation is a phase change. So it's just going from one phase to the other, still iodine. Water evaporates. That is also a phase change, still water. An ice cube melts. Still a phase change, it's still going to be the same substance. Which process is a chemical change? Once again, we are not looking, we can go ahead and cross out any options that are phase changes. So sublimation, evaporation, condensation, they are all phase changes, so they cannot be a chemical change. They are physical changes. So it's going to be option D, which is synthesis of magnesium oxide, because we will have to react magnesium and oxygen to make magnesium oxide. Which property can be used to differentiate between a 50-gram sample of solid potassium nitrate at STP and a 50-gram sample of solid silver chloride at STP? So we are now looking at two different substances. So your options are the phase. The question told you they are both solids, so this is not a good answer. Temperature. The question told us that they are both at STP, so this is not a good option. Mass, the question told us we have 50 grams of both, so that is not a good answer. So the last option that we are left with is solubility. So solubility is specific to the type of substance. So some substances are dissolve very well in water, others don't. So let's go ahead and look at a few more questions. So we also see some particle diagrams here. So for number 22, compared to the chemical and physical properties of the compound CO, the compound CO2 has, now as you can see, they are two different compounds, and whenever we have two different type of substances, they are always going to have different properties. I can kind of guarantee that this question or something similar to this is going to show up on your exam. So please make sure that you remember that whenever we have two different substances, they always have different properties, both chemical and physical. So your answer in this case is going to be different chemical properties and different physical properties. Then for number 23, we see a particle diagram. And it says, which two particle diagrams represent two different phases of the same compound? When it says same compound, that means we are looking for the particles that are arranged similar way. So as you can see here, according to the key, one atom is represented by the empty circle, and the other one is represented by the filled circle. So if you look at your option, there are some different types that we see. Whenever you see the same type of atoms together, this is classified as an element, just a diatomic element, because you have two atoms. When you see two different atoms combined together, that one is a compound. So what you see in the first particle diagram is that you have some elements and some compounds. So this one overall is a mixture of an element and a compound. In the second one, we see a compound and the same compound everywhere else in the diagram. So this one will be classified as a compound. In number C, once again, we see compound and element. So this is also a mixture. And then option D is going to be a compound as well, because once again, it's on the same diagram that we see everywhere. So we're talking about different phases. So remember, in case of solids, the particles are very closely packed. Liquids, they are slightly separate, so they have a little bit more space. Gases, they have a lot more space, so they are very far from each other. So we are looking at two compounds. So this is a compound and this is a compound, and we clearly see that they are two different phases, because in diagram D, the particles are close to each other, so that is most likely a solid. And then in case of B, that represents a liquid or a gas. So your answer is B and D, which is option D. Then for number 3, once again, we have diamond and graphite, two different things, although they are two different forms of solid carbon, but still, if they are named differently, that means they are different things. So they are going to have different properties and different structures. Then for number 5, we are looking for something that represents a noble gas. One very quick thing to remember about noble gases is that they are always monoatomic. So that means this thing, although it has the same element everywhere, and there's like a significant difference between the particles, so you can kind of say that this is also a gas, but this is not monoatomic, because this is not monoatomic, so it's not a noble gas. So your answer is option A. The rest of them, this one is a compound and this one is a compound. So that was it for the first topic. Let's look at the next one, which is about